let's be punctual then. So welcome, and thanks for being here. So this talk is about a very do-it-yourself project, and this is how I made some smartness into a dumb EV charger for for open source and for being viable for me to charge a car at my parents'. Okay, I'll try to speak louder. My voice is really getting a hard time. Thanks. Well, who am I? I'm currently a ClickHouse developer at TinyBird, which is a company we do data analytics. I presented Dracula. I co-founded this. I presented it on FOSDEM 2019 about privacy and showing who is tracking us through the internet. And I'm also Hipul is a Linux user group that exists in A Coruña, and we are organizing also a free software conference there, and CFP is open. So I made my own way of interacting with a car for charging, and first of all, the reason why I did this is this was a side project, and I wanted to learn Rust. So I ended up making this as an excuse, as a project to learn the language. And I talked yesterday at the Rust Devroom about how I did it. The talk of today is why I did it. So why? Well, I now own an EV, and charging cheaper than the public pricings are appealing. And my parents live in the countryside where there's very poor electric power. There's less than 2.2 kilowatts peak available. And most of the chargers that are currently available do a kind of this smart grid balancing and so on, but they are only interested in higher power output for like 10 cars or 20 cars, and this is not my use case. These balancing chargers exist, but first of all, they usually require physical wiring, which is cumbersome because when you have a car that is like 50 meters away from your circuit breaker in a different area, then you would have to like do a different do groundwork to put a wire, just a tiny little wire that only carries like 1 volt to check what's the amperage of the breaker. So it's really expensive and really not convenient for this to do. This is in kind of displaced, so it doesn't really make a lot of sense to like dig a hole through like 50 meters away to just go to the other side and charge the car there, because we already had AC there. We just didn't have that one wire. So the thing is also that cost matters, because part of deciding to purchase an EV was the cheap electricity and the convenience, like 10 years across, that it would be cheaper than running a gas car. So, and given that this is also depreciating asset, it doesn't make sense to spend more on chargers and other infrastructure than it's needed, because then you're just moving the milestones, and it doesn't make sense economically. And as I said, these are expensive. Should they? Well, the tech is very complex right now. Many of these chargers that are quite intelligent, they have hardware inside, like a Raspberry Pi or something like that, which is already quite expensive on itself. It's like 50, 60 euros, just the device. And if the goal is saving money, then this is my economics. If I charge at home, I would be charging at around 18 cents of an euro per kilowatt hour. And other than that, I have already been charging at an average of 34, which means that if I visit my parents twice a month for a year, I get a save of at most 80 euros. So there's a point where it doesn't make sense to purchase a charger at all. It's just less expensive for me to just charge outside, which doesn't make a lot of sense for the charging industry. So as I said, the turnkey solutions are expensive, and also the open source solutions that exist on Open EVSE and so on are also very expensive, because they use computing hardware that is quite expensive to have in an embedded device. And there are reasons for this, of course, but can we do more with less than that? So what I did is I tried to research for like what I think is the sensible way of going through this, trying to see what is already existing. How could I make it? What are the standards involved in charging? What are the projects that exist in open source that implement this, and maybe develop something that doesn't anything that is missing. And keep in mind that what I wanted to do is I wanted to just be able to charge the car at the maximum rate possible, but keeping in mind that things like having running water and having the fridge open and that the circuit breaker doesn't break is the main point here. And also maximize the car charge rate, because I could just charge at 1 amp, but that wouldn't take me very long. So there's two standards. How many of you know about how EVSEs charge and what are the standards about this? Okay. Okay, for the majority of the room doesn't, so let's talk a bit about this. There's basically two main standards about going this way. There's the left one, the IEC 61851. This is electric signaling that uses pulse width modulated signal, where depending on how much of the pulse is full, then this signals how much of an amp you are requesting. So for each 1% of the cycle that you add, this is 0.6 amps. This was based on an American standard before. And this is very cheap to implement. You don't even need an integrated circuit to do this. You could do it with a 555 timer, but you can also do this with an ESP32, with anything that has the capacity to output 1 volt and then have a couple of resistors and the capacitors to do the rest of the wiring. This is very, very easy to do. The bad thing about this is that since 0.6 amps is the 1% and the minimum is a 10% on the standard, you can't really tell the car to charge at less than 6 amps. And in my case, I had between 0 and 10 amps. So if I only have from 6 to 10, then for half the time where anything is being run at home, the car would just be sitting idle, which is not convenient. Then there's the more sophisticated ISO IEC 15118 standard, which is a lot more convoluted to implement because this is packet-based. On both of these things, what you have, if you have ever seen one of these chargers at the street or anywhere, you will see that there's 5 connectors. One of them is called the control pilot, and what it does is that one and earth is the only path where the charger communicates to the car. So this ISO standard, well, the PWM standard just uses that wire to make a pulse width modulated signal, which is very easy. But the ISO, what it does is, over that signal, it has to send Ethernet packets, which requires you to use something that is called a PLC. You may have seen this, for example, when you use there's these solutions where you put 2 devices on the AC directly, and then you have Ethernet over there. That's using this sort of the same kind of communication. The thing is, these modules are quite expensive. I didn't see them online to be able to purchase them for less than 60 euros. Maybe probably for integrators this is cheaper, but for me as an individual, I couldn't even participate of getting this in an open source hardware kind of thing. For less than that, and I would also have to implement over this Ethernet thing also the actual signaling with the car, which uses XML. So you would either have to do all of the XML signaling in some embedded kind of device, like an ESP32 or something like this, but the things that are already built, like in Open EVSE and some other projects, are using currently a full Linux OS with Python to run the XML parser, basically, which means that there's also a lot of overhead in terms of like the kind of computing devices that we are using for this. So maybe there's a third way. I used something that is not standard here, which is the car vendor API. There's for different providers. This is the one I'm using, where you have an API that using the own car 5G card, you can ask it how much it should charge. This is possible in AC because when you charge a car in AC, it's the onboard charger in the car, the one who knows how much it can charge. So you can request it directly to that. So what did I do? I first bought the dumbest charger I could and the cheapest one I could find to try to understand how this works. Step 2, disassemble it to check whether the cheapest thing has enough of what it needs to not break apart and catch up in flames. And it does. Basically, the one thing that is the most expensive, the thing that is most expensive here, if I wanted to do this on my own, which I also thought about doing, is the big wires here. I'll step away from the camera for a moment. These 3 wires, the 5 meters of cable, are the most expensive thing on a charger. Just the 5 meters of wire can run you maybe like 40, 50 euros of the 60 that this costs, is basically copper. Copper is really expensive nowadays. The rest of it is very cheap electronics. You have a couple of relays to switch on and off the AC current, and then, well, you can see there's not much. The one thing that is maybe a bit interesting to see here is that there's this small chip. This is a Higa device ARM chip. This is a small ARM chip that is doing the pulse width modulated thing. I could change this and program it to do whatever I wanted, but I couldn't find the data sheet easily online to flash it. So it was, if I wanted to do this with the ESP standard, I could just remove this wire. This is the control pilot that I mentioned, and run this through my own microcontroller, and then talk to the car, and then put another wire here so that the charger knows that I'm talking to something that is like the car, so that the charger knows I'm talking to something, the car knows I'm talking to something, and I put something in the middle to make things work. This is what I thought I had in mind at the first time, but then I saw the car API. It was very much easier to do it that way, so I started in that. But if we all wanted to do something with this, this is very, very possible and easy. This is basically a Cortex M3 with 72 megahertz. It's a really, really small microcontroller. So in order for me to be able to do this smart and be able to do a grid balancing, I would have to build a watt meter, and I wanted to do this wirelessly so that I didn't have to run wires over the countryside to tell the car, plus something to let the car know how many amps to request. So this watt meter, instead of all of the money that it would cost to other things, you can see this is really cheap to do. The current transformer is just, I'm not sure if I don't think I have here the picture of the city. Anyway, this is basically the current transformer is something that it's a coil that you put one wire over it, and it will measure in volts how many amps are being passed through the wire. Really small electronics device, not even electronics. And then a power source to power this from the grid. And then, something to the card, which is an API. For doing this with the ESP32, I used Rust because you can see my talk yesterday. Because it just works, it's easier to build this than with the C++ SDK, in my opinion. If you want to do something with this, I highly recommend it. And then here it is. This is basically the current transformer. This is running to AC directly, and then this is the current transformer. You just put one of the wires over here, and you will measure how much. It will measure 1 volt over this line if there's 30 amps here, and otherwise it's just linearly whatever it is. So now I could do this manually. I could just go and curl every couple of seconds for the web server that I put on this device. Then next step, I could automate it and set the charging amps to the car every few times. Then I could put this in a more sophisticated script, but it's still running from my laptop. This is not ideal because, all of this requires me to have a laptop here, have LAN access, and, I just have to remember to do this. So next thing, talk to the car automatically. Basically, these 3 things. So I used a backend with Rust, and for this I I used Rocket because of several reasons regarding Rust. Basically, to ensure that the IP requests were valid with the database tokens and so on. And then I even did a map that renders the energy usage of the house over a period of time. This was even useful to me outside of the EV thing, because we noticed that when at this home we have our running water comes from a well, and we have a water pump to get it through. And we noticed that we had peaks of electricity running due to the pump by just looking every few seconds on the wire, and we could notice that we should put something to filter this noise on the AC line. So anyway, I didn't like this very much in the idea of using the car vendor API. I would have preferred to use one of the standards, but unfortunately, as I said, there's no current open source implementations of talking via the XML interface with the car. That doesn't require you to have a full OS as such. So I started with this, because start small and then grow incrementally from here. This is very easy, and if we wanted to make to change this to be implemented for some other kind of charger or some other kind of car API, this would be very easy, because most of the work is already done in a way that is pluggable. So you just need to change the EV charge handler kind of thing, which is something that you only have to implement two things, well, actually three. One is the kind of object that you want to keep as state of what you have internally, which can be whatever you want. There's and then only two methods. One of them is get the state, so that we can, and the state can be whatever you want with some restrictions that I have on the next slide, and then request something to ask the car to charge at a specific rate. This can be in the charger, in the car, wherever it is. And then there's the state. The state has to implement 5 things, which is whether it's charging or not, because if it's not, then we don't care much about things. Whether it is starting, so that we don't ask repeatedly things until it's done. And then get the current charge, get the last requested amps, because this may not be the same, because it takes a while for the things to ramp up. So this should measure, this should remember what was requested, and this should measure actually on the car. And this is, well, I also got this get car distance to the point in kilometers, because if you have a way to know this, then we can just sleep for hours on the backend and do nothing at all, because if you are 500 kilometers away, you don't have to ask for the state for at least 5 hours if you're going at legal speed limits. This is the interface that I am rendering right now on this. So you can see every 3 to 6 seconds, something like that, the watt meter is pushing a packet with the amps at that point, and then you can see both the peaks in red and then in blue the average over a few seconds of that of the energy usage. This was quite fast for me to do. I took approximately maybe 1 month of total development time, which I think it's not that much to be able to charge a car from scratch without with a budget of 70 euros at most, because the charger was 63 plus the $3 of the ESP plus 4 of the other current transformer, and maybe a total of 30 cents of wire. So I mean, compared to running an open EVSE, which retails for more than double that, I think this is a win in this case. I wanted to highlight this on this room because, well, basically, because there's nothing currently that does this. I had to do this because I didn't want to run a full Linux just to talk some XML with car, or just to send a few packets to an HTTP API. This this costs one order of magnitude less than what we have on the current open source space. And I think that sometimes, and this is maybe a bit more of a general comment, but I believe that also in my work, we work with highly potent machines with lots of resources, but then when we go to the real world, many of the devices that our users are using don't have as much processing power for maybe a website or for maybe anything else. Okay, and also in general, I think that this is a bit of a waste of resources in the sense that we have a whole Raspberry Pi where we could be using something that has 100th of the computing power and still do the same thing. So it's less e-waste, and all of that, right? Then future work for this would be, it would be very, very great to be able to create an ISO 15118 charger that doesn't require a full OS. And of course, being able to push the watt meter through Matter, because this is like the new IoT automation standard, and I think there's no definition of a watt meter in the Matter standard. Please correct me if I'm wrong, if there's anything from the CSA that knows more about this, but I didn't find a way to publish this information through that. And I believe that for anyone with a solar roof or with any kind of grid management system, it would be great to be able to automate this in the same way that the rest of the home automation systems work. And this is like the new standard going forward. And currently, all of the energy-related parts of balancing are done in a separate protocol, in a separate way. And I think that converging that could be a good idea. But I'm not sure. And I'm open to questions here and or for discussion for the 5 minutes we have, 4 minutes we have. So yeah, that could be interesting. And yeah, in general, just well, think about all of the CPU hours that we have wasted on the chargers that we have on the streets and the hundreds of euros that every one of them is costing, that we could just remove from existence just by putting something smaller there. And that's it. Now, if you have any questions, anything to add here, that would be awesome.
Although there's a standard stack which is used for when someone has smart metering or something. It's not Bluetooth. I'm failing to remember what the moment is. There's a standard stack there, including an energy stack. You probably know, which definitely covers metering because it covers the metering of a house and so on. So that might be another way of tackling it, because there's a bunch of software already written around to do some of this sort of thing for you.
Okay, so
Matter might be too new to be commercially adopted for that, whereas the other stuff is in every smart meter in Europe, for example.
What is it called?
I'm failing to remember. It's sitting on band 30 or whatever. It's very common. Every consumer access device and so on, they run this protocol stack. Zigbee, thank you. There's a Zigbee energy profile.
Yeah.
Thank you.
Okay.
Which might be another way.
Sometimes can you sum up the question?
Oh, sorry.
Yes. All right. So what was being said is that there's a different energy standard that was older that exists, that is called Zigbee, and in Zigbee there is an energy profile that you can run, and basically, and this is probably a way where we could go forward with this. I can complement that with saying that I believe that all of the Zigbee energy profiles are available in Matter, so maybe there is a way of doing this. I believe that this is the case. So yeah, maybe I'm just wrong and this exists and we can do this.
Maybe it's your answer, we both win, right?
Yeah, exactly. Yeah, so anyone has, I don't know if there's anyone from the open EVSE community here, maybe, no? Okay. Because, yeah, I mean, it would be great if we could make this smaller in a way that is, yeah. Any other question, comment?
Yeah, very good.
Okay, thanks.
Thank you.
All right, thank you.